we're going to look at our final combination or composition of transformations. And all we're going to be doing today is putting together things we've already done. This is a great review for the unit test as well. So, because we're going to look at all our different types of transformations. So basically what we're going to do is we'll start composing maybe a translation with a dilation and other things like that and see what's going on. Now, the best way to do this is a lot of times to do it off the coordinate plane first and then graph what we've got when we're done. So I'm going to go ahead and put a graph out here, but I'm not going to actually draw it. I could put the original on there to start with, but I'm not going to try to do this all in the coordinate plane by myself. Triangle ABC has vertices. A is at -4, 1, so I'll go ahead and graph that. There's A. B is at -2, 2. And C is at -2, 1. That's a little bitty triangle. Little bitty right triangle. Okay. I want to see what happens after a translation and a dilation. So all we're going to do is we're going to do this very quickly, one at a time. And again, the trick to doing this is try not to do everything at once. Do it one point at a time. Do it one transformation at a time. So first we're going to find A primed. A primed, we're going to notice, is a translation. X coordinate is going to add 5. Y coordinate is going to add 1. So A was at -4, 1. So -4 gets to add 5 to it. That takes to a +1. The 1 adds 1 to it. That takes me to a 2. B primed. B started at -2. 2 again. The X coordinate, we're going to add a 5 to. So -2 plus 5 is 3. And 2 plus 1 is also 3. C primed, do the same thing. The X coordinate is -2. -2 plus 5 again is 3. And 1 plus 1 is 2. So that's my first. That's what happens after my translation. Next, we're going to dilate. We're going to dilate with respect to the origin, this particular figure. So now we got to find A double primed. And we'll notice that my dilation is written a little differently here. Instead of writing K equals 2, it's giving us a rule for the X and Y coordinate, 2X, 2Y. It has to be the same for it to be a dilation. Those two numbers must be the same. We could also say a dilation of K equals 2. So A double prime is going to be at 2, 4. B double primed is going to be at 6, 6. And C double primed is going to be at 6, 4. So I can go ahead and plot that new A double prime, B double prime, C double primed. I'm at 2, 4. There's A double primed. B double primed is at 6, 6. So 1, 2, 3, 4, 5, 6. 1, 2, 5, 6. There's B double primed. And C double primed is right there. So sure enough, we slid it over and then we enlarged it. Okay? And if you wanted to see the result of the first transformation, you could graph A prime, B prime, C prime too. A prime is at 1, 2, right? 1, 2, excuse me. I put that slightly in the wrong position. There we go. There we go. So you get the idea. We do them one at a time. We simply combine. This one, we're going to do a rotation and then a dilation. That's fine. Again, let's remember, we're just doing a segment, which is nice, but it's a great chance for us to review our rules for rotation in the coordinate plane. Again, you do not need to memorize these rules. These will be given to you on the test. Make sure that you ask for them if I forget to write them on the board. All right. So my point, C is at -2, 2. So C primed, because we're going to rotate 90 degrees, 90-degree rotation, my rule is AB goes to -BA. So this +2 comes first now and becomes a -2. And A flips to the second and remains the same sign, so -2, -2. D was at 2, 2. So D primed, excuse me. D primed, again, the second one becomes first and changes sign, -2. The first one becomes second, remains the same. So -2, and -2, 2. A lot of 2's there. Too many 2's. Ha, made a pun. All right, and then the second transformation is we multiply all the coordinates in half. That's actually going to be ridiculously simple. Half of -2 is -1. And so that's going to be at -1, 1. And we could certainly just go ahead and plot that in our coordinate plane and be very happy. Not a big deal. Again, first we're going to reflect in the x-axis and then a dilation of 1.5 for each of these. So again, reflecting in the x-axis, if you're not sure of your rules, this is one you can very quickly figure out, okay? If I have a point here, A, B, and I want to reflect it in the x-axis, we're going to go down here and reflect down here. What's going to happen? My x-coordinate stays exactly the same. My y-coordinate flips. So AB goes to A negative B. Okay? That's my rule for reflection in the x-axis. And again, it's one of those that you can memorize it, but I never bother memorizing it. I just do a quick sketch, go, okay, AB is up here. Oh, if I reflect in the x-axis, the x-coordinate remained the same. The y-coordinate is the one that changed. So F primed, again, 1, 2 becomes 1, -2. G primed, 4, 4 becomes 4, -4. And H primed, 2, 0 becomes 2, -0, which is still 0. Why didn't that move? Well, because the point was on the mirror, right? If that's 2, 0, okay, 1, 2. If that's 2, 0, then obviously we're reflecting something that's on the mirror. It's not going to move. Next is dilation. We're going to multiply each of those by 1.5. So F double primed. 1.5 times 1 is 1.5. 1.5 times -2 is -3. G double prime, 4 times 1.5 is 6 and -6. H double prime, 2 times 1.5 is 3, and 1.5 times 0 is 0. So now we've got our new coordinates. Simply plot them. Boom, done. Like I said, this is a great review of all the things we've done so far in this chapter. This is working it backwards. They give you the picture, ask you to describe the transformation. Okay, well, a couple things going on here. One, you start at PQRS. Let's note this. We start with PQRS and end up with WXYZ. So clearly we're going to be reducing in size. Clearly there's a reduction. The question is, how much is the reduction and what else is going on? Because it's obviously not just reduced, it's also going to be somehow reflected or something else going on. So I think it's fairly obvious here that this is going to be a reflection in the y-axis because I look at R and Y here. And if I just flip over the axis, it's going to stay the same thing. We've got a pretty clear reflection here. So I'm going to hazard a guess that we're going to reflect in the y-axis. And second, we're going to dilate with K equals, what's our scale factor going to be? Well, I have to find, in order to do this, corresponding parts. I have to find two parts and look at how the length changed. So for example, I can pretty much tell that WZ corresponds with PS. And I can see WZ is 2 units long. And I can see that PS is 1, 2, 3, 4, 5, 6 units long. And that it's small, that the image is smaller than the original. So K here is going to be 2 over 6, or 1/3. Now, that's my guess. How can I test my hypothesis? Well, I could very simply, to test my hypothesis, if I think that's the case, I could find the points P, Q, R, and S. In fact, let's just pick one point. Let's pick P. P is at -6, 3. If I reflect that in the y-axis, P, and I could do this pretty easily, is going to go to +6, 3. Okay, if I just take P as 6 units over here, then P primed has to be 6 units over there, is P primed. Now, if I'm going to dilate it with a factor of 1/3, what's going to happen? Taking 1/3 times 6 is 2, and 1/3, it's positive 1/3, by the way. 1/3 times 3 is 1. So P double primed would be at 2, 1. And I look, there's W primed at, there's W right there at 2, 1. P double primed does indeed work there. And I could do the same thing for Q, R, and S to prove to myself that my hypothesis was correct. So this is kind of a visual and do you really understand what's going on thing. You're going to have to puzzle these out, but they're not horrible. And in fact, they're kind of fun, I think. Okay, I've got a strange idea of fun. What's going on here? Describe a similarity transformation that maps this to a quadrilateral STUV. So DEFG is my original, and STUV is my copy. What is going on here? All right, well, when I look at this, what do you kind of suspect is happening? I kind of think we got a rotation going here. Let me just kind of flip my picture once. Obviously, it's smaller, but notice it kind of goes down to the right. And notice that orientation. Yeah, it looks like I've got a rotation going on here. In fact, it looks like I'm rotating 180 degrees. So I'm going to guess rotate. That was a horrible rotate. Let me try spelling that again. I know my handwriting is not great, but that was exceptionally horrible. So let's say we're rotating 180 degrees. And then, whoops, step 2, decide am I going to go A, B, or 1, 2. Step 2, we're going to dilate with K equals. Okay, now we got to figure out what K equals. Well, we're going to try to figure out how long a segment is. Unfortunately, we don't have any horizontal or vertical sides here to do that. So I got to kind of guess a little bit. But I noticed something. I noticed that from the origin up to G is 1 unit. And from the origin down to this kind of point V down here is 1/2 unit. So it looks like it's about half as long. Looks about like it's half. So I'm going to go ahead and K equals 1/2 and throw that in there. Again, how do we test it? We pick a point. In fact, we should probably pick several points. But let's just pick point E. E is at the point 1, 4. If I rotate E 180 degrees, E primed, let's look at our rules again, because these we don't have to have memorized. For a rotation of 180 degrees, we switch the coordinates. AB becomes -A, -B. So E primed would have to be -1, -4. And then a dilation of 1/2 would put E double primed at -1/2, -2. Do I have a point? Do I have the corresponding point at -1/2, -2? Is the point that corresponds to E should be T in order. And sure enough, T is right there. I'm pretty confident of my guess. To be sure, I would probably want to check at least one other point, and you could choose whatever and do the same process. Let's pick F. F was at 4, 0. So F primed is going to be at -4, -0, which is still 0. And F double primed is going to be a dilation of 1/2, is going to be at -2, 0. F double primed, F corresponds to U, so it has to be UW prime. Is U at -2, 0? Yes, it is. I'm pretty confident at this point that I've done the right thing. So a little guess and checky, kind of visualizing what's going on and making it work. And if you're having trouble with it in class, by all means ask for help. That's why we're here. That's why we do these things in class. All right, we'll see you in class.